Okay, hey guys, so today I'd like to present to you an interesting phenomena and a cool circuit and also sort of an application of electromagnetism. So this here is a magnet. I've sort of hung it onto my desk light here, but yes, it's a magnet hanging there to this circuit. That's an electromagnet, so that's sort of the interpreter from one to the other either way. Now I'll just turn it on and show you a couple of cool things. So right now the magnet does repel, as you can see by the motion of the magnet, but now if I do slide this, right, it stops repelling at that point, but more interestingly it's kind of starting to dance around the electromagnet here. And if I change the frequency of the ticking, which I'll explain as well, the frequency of the dancing also the oscillation seems to change. It's kind of showing us that they're related, which I'll also explain how. Right. So that's the cool circuit of the day. And now sort of a couple of the hows, whys, whats of the circuit. Right, so what the circuit is, it was called paperclip oscillator in the manual that came with this. And yeah, normally that iron would be a paperclip and it would be dancing. It's pretty cool, but I couldn't get a paperclip either way. How the thing works is basically that's a solenoid, and so it turns on, the current in it turns on and off because of this component here, which I'll delve into it now actually. Basically what this does is, if there's current here, this armature, I'll show you in a second, let me just make it so that the armature will stay up, but the armature would stay down because there's an electromagnet underneath it, which you can sort of see over here. And then when the current is turned off, the electromagnet will turn off and the armature will return back. And the armature moving switches the current from this opening to this opening. So first these two openings would be connected, completing the circuit when the armature is down, but otherwise it would be connecting these two, which would be closing opening the circuit. This will be closing. This is a variable resistor. Its resistance changes. I believe this side is the highest and this would be the lowest, judging by the way the circuit works. And changing it changes the frequency of current oscillating here, which changes the frequency of that. Now the way this is set up, of course, when it's on, when this is on and the iron bar is a temporary magnet consistently, it repels this magnet. But when it's off, because it's iron to a magnet, they attract. So that's how that solenoid part works. Now this area is generally the part I cannot really understand. So a couple little things I was able to derive from a brief reading and my knowledge of circuits. This is a transistor, and basically if current passes through this point here, then current will also pass through this other opening over here. Now that basically sort of gives us a way for circuits to turn themselves on and off. And this is similar, except I think the charge changes or something specific like that, where this would be almost sort of a positive charge, so current can go from here to here, whereas over here it would be current is coming from here to here, which is what these arrows probably indicate. Now the capacitors, I'm not sure exactly how they work, because there seem to be almost 3 different ways electromagnets can go from the battery to this point here. So I'm not sure how the capacitors handle that fact, because current can go through this capacitor, you can go through the resistor and then this capacitor, or through here, but I'm not sure what current chooses to do when or how. And yeah, so that's the circuit, that's the basics of the circuit and the dancing electromagnet. Alright, just show it again because it's fun. Either way, yes, that's that. Thank you.